In this video, we'll describe three main types of machine learning: supervised, unsupervised, and reinforcement learning. Then, in the next one, we'll explore deep learning, a sophisticated subset of machine learning powered by neural networks and inspired by the human brain. If this sounds too abstract and complicated, please don't worry. We'll talk about the intuition of these AI techniques without getting into too much detail. Supervised learning excels when we work with labeled data. In the earlier example, the training data set reveals whether a picture contains a dog. This is how the algorithm can learn to classify new pictures as dog or not dog. We've provided the ML model with an extensive training dataset with labeled data, and it knows what to look for. Later, when we provide a new picture, it can identify whether it contains a dog based on the feedback given during training. This is a classification problem solved by supervised ML. The other primary application of supervised learning is predicting an outcome. Remember when we discussed the real estate agent's mobile app in our last lesson? Well, the dataset with past house sales transactions contained both known prices and features of the homes. We didn't merely highlight home features. This is an example of supervised learning too, but it's used for prediction, also called a regression problem. When a user inputs the characteristics of a new home into the app predicts the new home's price based on its features and historical information for similar homes. So, simply put, in supervised learning, we explicitly train the model with known outputs to guide its learning. In unsupervised learning, we process data without labels. For example, in a dataset of 10,000 animal pictures, half feature dogs, and the other half various animals. But we provide the machine learning model with no labels or indications. It will need to scan through all pictures and look for patterns. Ultimately, it will be able to distinguish specific groups and individuate them. We'll have a group of dogs, a group of cats, and so on. The ML model, however, doesn't specify the contents of these images. It merely indicates that they share similar characteristics, grouping them. Unsupervised learning is helpful in many situations. First, labeling data is costly and not always practical. Moreover, sometimes we don't know what relationships we should look for in the data, so it makes sense to have the algorithm find these interesting relationships first. In this way, a supermarket chain could find clusters of target customers with different behaviors, or a real estate agent could use an unsupervised model to determine which types of properties are sold most often. Another key ML type is reinforcement learning, which operates without labeled data and is applied in specific scenarios where the machine figures out how to reach a designated goal. Reinforcement learning shares with supervised ML the understanding of the desired output. We essentially direct the computer to optimize our goal achievement. But unlike supervised learning, we don't provide labeled data to the ML model. Instead, we create rules. The ML model learns through trial and error within specific parameters of our created rules. Reinforcement learning thrives in robotics and online recommendation systems. For example, platforms like Netflix use reinforcement learning to enhance recommendation systems. Unlike traditional methods that rely on labeled data, which indicates which TV shows a user might like, reinforcement learning employs a system where the model learns from user feedback through interactions. Initially, Netflix may provide random show recommendations. As a user interacts with these suggestions by watching a show, adding it to their list, or skipping it, the system gathers feedback. Positive interactions, like watching a full episode, signal the model to recommend similar content in the future, while negative responses, like skipping a show, guide it to adjust recommendations. Over time, the model refines its predictions to better align with individual user preferences, constantly adapting to new viewing patterns and behaviors. All right, so that's the intuition behind supervised, unsupervised, and reinforcement learning. In the next lesson, we'll examine deep learning, a truly fascinating feat of computer science.